Hi everyone, welcome back to the Spark Summer Series. Today we're going to be going over experimental design part 2, which is going to be based on statistics. So in today's video we're going to be covering standard deviation, sample mean, standard error of the mean, and a 95 confidence interval. So let's dive right into it. So here I've already gotten a start and written all about standard deviation. So standard deviation is the variation of the data, which just means that standard deviation is the extent to which the data or the points of data are spread out from the mean. So it's just how much the data is spread away from the mean. So in the second bullet point, we can see that it's a bell-shaped curve, meaning that it has a bump, and that bump depends on the amount of data points you have. So a higher standard deviation means more spread out data, which means a larger bell-shaped curve. And a higher standard deviation is just that there is a big spread or larger difference between the data points and the mean. So underneath that, I've written the formula for standard deviation, which is the square root of the sum of the data points subtracted by the mean squared over the degrees of freedom. So if you're a bit confused as to how to solve it or what that means, I've written the steps below. To begin, you need to find the sample mean, or just the mean, which is denoted by x over the line over it. And then step 2, you need to subtract the numbers and the mean. This just means that you have to subtract the data points, each individual data point, from the mean. And then you have to add all of those data values you found together. Then you have to divide that sum by the number of values minus 1, which is just degrees of freedom. So over there in the little bubble I've written, the n minus 1 is the degrees of freedom. This is a very important term which you'll need to keep in mind for later in the video. So n is the sample size, or the number of data points, and like in step 4 says, you just subtract it by 1. And after you've done all that, you take the square root. So when I solve standard deviation, I like to solve all of these steps individually rather than plunging it all into my calculator. And when you break it down into steps, it's a lot easier and ensures that you get the right answer. Okay, so now that we know what standard deviation is, let's go over what sample mean is. So you need sample mean, or just mean, to find standard deviation, standard error of the mean, to graph the 95% confidence interval, and for chi-square testing, so we can see the significance of the mean. Okay, so right under standard deviation, I've written about sample mean. And no worries, it's super easy, a lot easier than standard deviation actually. So sample mean is just the average value in a sample, and a sample is a collection of just different data points. And a good sample mean would include a lot of data points. So here I've written the formula of sample mean, and as I mentioned when we were going over standard deviation, it's denoted by x with a line over it. So in order to calculate the standard sample mean, we use the formula, but if you're a bit confused as to what that means, I'll explain it. So step 1 is the sum of all values in a sample, which just means that you add up every single data point you have. Then you divide it by the number of values in a sample, or by the sample size. As I mentioned above, n is the sample size. So all you do is add up all the values you have and divide it by the number of values you have. And that's it. That's how you find sample mean. Alright, so now that we know standard deviation and sample mean, let's dive into standard error of the mean. So here I've written about standard error of the mean, which is just denoted by SEM, or SE, with the symbol of a mean, which is x with a line over it. So standard error of the mean is just the standard deviation of the distribution of sample means. So if you're a bit confused as to what that means, I'll explain it better. So standard error of the mean is just, so suppose if you were to take many samples of a population, and each mean would be different because each population sample would be different. So all these sample means would be distributed around the population mean. So then that makes standard deviation, or the standard error of the mean, is just the standard deviation of the distribution of those means of different populations. So in other words, standard error of the mean is just the standard deviation, which we already went over, of different populations when taken together. And sample size is inversely proportional to standard error of the mean, which simply means, in simpler terms, that when sample size increases, standard error of the mean decreases, and vice versa. So if sample size was to decrease, then standard error of the mean would increase. So the standard error of the mean is super easy to find. It's just dividing the standard deviation by the square root of your sample size. So we already went over the steps to find standard deviation. So we'd go through all those steps, find standard deviation, and then take the square root of the number of values in a sample size. And then we divide the standard deviation by the value which we got in step 2. That's why, as I mentioned before, it's very important to break up these steps into different parts in your calculator rather than plugging it all in at once, because you don't know if you'll make a mistake. Okay, so now that we have a very good understanding of what standard deviation is, sample mean, and standard error of the mean, we can go into 95% confidence interval. And keep in mind, as you may have already noticed, a pattern, all of these things are related to each other, which makes statistics even simpler. So here I've written about the 95% confidence interval. So to begin, sample mean, or the mean, is an estimate of a population mean, which we went over before. So it's talking about how good is an estimate. That's what mean identifies. So with the sample, you can estimate the interval or the range of values, which includes an actual population mean. So a 95% confidence interval is just the range of values which may potentially include the actual population mean. So a 95% confidence interval tells you that if you were to collect many samples from the same population, the population mean, or the average mean, would be within the 95% confidence interval for each sample 95% of the time. And in order to find the 95% confidence interval, all you have to do is multiply the standard error of the mean by 2. So as you can see, all these terms play together. They have a role within one another. So the absolute foundation, the most important thing you need to know is how to calculate sample mean. From there, you can calculate standard deviation, then standard error of the mean, and then you can find and plot on a graph the 95% confidence interval. Okay, so now let's do some review questions and example questions. So here I've plotted 2 graphs. Both are standard deviation graphs. So we can see it's a bell-shaped curve. So the first review question is, which graph has a larger standard deviation? So go ahead and pause the video and see if you can figure it out. So the answer was the first graph, because it has a larger spread and we can see that it's a lot wider, meaning it has a larger standard deviation. Now let's do an example question. So here I've written a little data point for the dog names and the speed of each dog. So go ahead and find the mean or the sample mean of this data. So the answer would be 23.7. And remember to round to as many decimal places as possible. Here I rounded to 1 decimal place, but it's ideal to round to at least 2. Now go ahead and use these steps to find the standard deviation, and the second step would be to find the sum of the square differences. So next you would continue for using all the steps of standard deviation. So we'd find the sum of the square differences, which would be 424.67. Then we would divide by the degrees of freedom, which is just n-1, and we would get 212.33. Finally, we take the square root, and our final answer would be 14.6. Alright, so now you're all prepared to go ahead and do standard error of mean, 95% confidence interval, standard deviation, and to use the sample mean to find all of those. Thank you, and stay tuned for more videos as part of the STEM program in the Spark Summer Series.